currents in my direction, sometimes both are in the opposite direction. Okay. So is this fine? Is this okay? Any questions about this? This is the mesh analysis. This is how you do it.
Yes, it's fine, sir.
Okay, so take a screenshot if you want, so you can do the exercise on your own later. Before we go to another exercise. As I said, we will try to do 5 or 6 today. There's 9 exercises here. Okay, I'm gonna delete this, but before I move, what if the question says nodal? So in this case, I'm gonna have this node as my reference, and this is my Vn, and I'm gonna try to find the one equation for this one. You can try this as well, but we're gonna go to the next, just to give you an idea. Okay, so now this question here, I'm gonna actually take it down. Okay, so this is another question, another mesh analysis. This one, it doesn't have current source in between. So this is the other case if you have mesh currents like this. So I'm gonna do the polarity here according to this mesh. And then the polarity according to the second mesh current, which is gonna be like this. Because this current is gonna go this way. While this current, the first current, is gonna go in this direction. So the first mesh, remember when we do mesh analysis, we do sum of the voltage equal to 0. So we're gonna have 0, and we're gonna put the voltage cross here. So if I start from this point, from negative to positive, I gain 12. Then from positive to negative, I'm gonna lose. Then the third one, from positive to negative, I'm gonna lose. Here, what is the voltage? Resistance times the current. So 10, the current here is I1. Here, resistance is 30. And the current, I have two currents. So the one in my direction is positive, which is I1. And I2 now is opposite. You see at here, I1 is going down, I2 is going up into this resistance. So it is minus I2. I can simplify the equation. 12 minus 40 I1 plus 30 I2 equals to 0. So I can rearrange the equation, move these ones to the other side. 12 equals to 40 I1 minus 30 I2. This is the first equation. Now the second equation, I forget about the first. I'm gonna start the second loop here, the second mesh, different color, just to show you that this is another one. Again, the sum of the voltage equal to 0 because it's a mesh, it's a loop. I'm gonna start from here, negative, negative, and negative. If I start from the other way, it's gonna be positive, positive, positive. But the equation is gonna be the same. Okay, it's gonna be the same equation. So if I go this way from this point and go around, the voltage here is negative, the voltage here is negative, the voltage here is negative. Okay, so it's gonna be negative voltage and negative voltage and negative voltage equal to 0. So the first voltage is the resistance, 30. And now the current with me is I2. And the current against me is I1. Because there's two currents in this resistance, two mesh currents. Then in the R2, there is only one mesh current, which is the second mesh current. Then this is the 6 here. So simplifying this one, minus 50 I2 and plus 30 I1 minus 6 equals to 0. So I'm going to rearrange this equation, move the 6 to the other side. So it's going to be 6 equal to, I move 6 to the other side, 30 I1 minus 50 I2. This is the second equation. Now to solve these two equations, you can do elimination or substitution. You can use matrices if you want, but it's up to you. You can use your calculator. Calculators now solve equations easily. So I'm going to put the two equations. And look into something that, so 12, 40, I1 minus 30, I2. The other one is 6 equal to 30, I1 minus 50, I2. Okay. So you can do elimination, you can do substitution. I can multiply here by 3 and here by negative 4. Then I add. So if I multiply by 336, 120, 90. If I multiply by negative 4, this will be minus 24. This will be minus 120. And this will be plus 200. Then if you add 12, 0, and this is still minus, sorry. So this is plus 110, I2. So I2 will equal to 12 over 110. Then you can substitute and find I1. So this is a second question. You can copy this, okay? Before we go on to other questions. This is a tutorial for lecture 3 and 4. It's not for the lab. It's not for the lab. The lab question is very simple. Lab 4 question is very easy and simple, and I can show you how to do that one at the end. Okay, so I'm gonna move on. This is another one. This is similar to the lab question, okay? Similar to the lab question. This one is nodal. It's similar to the lab question. This is the lab question basically. So let me just do this since. So this is the lab question here. Use nodal analysis to find the currents in, okay, voltages, whatever in the circuit. So when we do nodal analysis, this node is going to be my reference. This is the lab question, it's just different numbers. And this is my node, Vn. One equation, I don't know the current, so I'm going to assume all leaving. So sum of the entering currents equals to the sum of the leaving currents. Entering, I assumed nothing. Leaving 3 currents, and I'm going to find them using the Ohm's law, voltage divided by the resistance. So this current is going through this resistance. The voltage here is 10. So it's Vn minus 10 divided by 4. This is this current, Vn minus 10 divided by 4. The second current, which is this one here and this time, Vn minus the voltage here is 12. Now, if the polarity here is different, it means it's minus 12. Let's say it's like this. Then it will be minus 12 here because you go from the 0 volt, which is this side. If you go up here, you lose 12, so the voltage will be minus 12. Now here it is plus 12 because you gain. You go from 0, you gain 12 to this point. So this is Vn minus 12. This is the voltage across this resistance, Vn minus 12, divided by the resistance, which is 8. The third one here, Vn minus 0 divided by 8. Easily I can multiply by 8. So I have 0, 2Vn minus 20 here, plus Vn minus 12 plus Vn. So I multiplied by 8, 8 cancelled out, 8 cancelled out, 4 cancelled out, and I have 2 in the top. So from here, 0 equals to 4Vn and minus 32. 2 and 1 is 4, minus 20 and minus 12 is minus 32, so Vn equals to 8 volt. This is Vn. Now if I want, خلاص, I'm done with my analysis. I found the voltage Vn. I can answer the question now. I don't care about these values. Vn here is 8 volt. So the current, now the real current, not what I assumed. The voltage here is 10. The voltage here is 8. So the current is going this way. The voltage here is 8. The voltage here is 0. So the current is going this way. The voltage here is 8. The voltage here is 12. So the current is going this way. From the high voltage to the low voltage. The voltage here is 12. The voltage here is 8. So it's going to go this way. So now in R1, the current equal to the voltage, which is 10 minus 8. This is the voltage across the resistor, divided by the resistance, which is 4. So this is 0.5 ampere, and it's going to go this way. Because the voltage at this here is 10 terminal, and here is 8. The voltage the current goes from the high to the low voltage. In IR2, this is 12 at this side, 8 at this side. So 12 minus 8 divided by 8. This is 0.5. And it is going this direction. IR3, the voltage is going from here to here. This is 8 minus 0. The voltage is 8 minus 0 divided by 8. This is 1 ampere. And it's gone down. So makes sense. 0.5 ampere comes from this side. 0.5 ampere comes from this side. Both together give me 1 ampere going down. This is the answer for this question. This is the lab question, just different numbers. So the equation is going to be exactly the same. The values are going to be different. Is this okay?
Yes.
You can take a screenshot before we actually try to do. I'm going to go to the last questions now. Not the middle questions, but I'm going to go to the last questions. Start from the end. Just because the last ones are the long ones. Here are the answers here. Okay, those are the answers. This is the answers for the questions, the key answers. Now I'm going to do this question here. It says, write the node voltage equations, just the node voltage equations. So I'm going to put the space here so we can write that. Oops. Okay. Here's the, how many nodes do we have? When we say is write the node equations means just don't solve them, just find the equations. It's going to be long to solve the equations. So first, reference. This is the point I'm going to use as a reference. V0. Then this is a node called V1. This is a node called V2. I'm going to use different colors for them. So this one, this node is V1. Everything connected to it will have the same voltage. 3 branches are connected to this node. Then node 2, this one here. 3 branches are connected to this node. Then the node 3, which is this one here. 3 branches are connected to this node as well. So I need to find 3 equations. Look what is between node 1 and node 2, a voltage source. When you have voltage source between nodes, you're gonna do super node here. So voltage source between 2 nodes. We're gonna use super node between the 1 and 2. So what is the super node? When we do super node, when we have voltage source between 2 nodes, like this. So what I'm gonna do, I'm gonna say, okay, the source equation 12 angle 0 equal to what? The voltage here, the positive minus the negative. So it's V1 minus V2. This is one equation. How many equations do I need? 3, because I have 3 nodes. So this is one equation. Now the second equation, which is the trick thing here, I'm gonna actually use these 2 as one node, a super node. So let me just put a different color, is like this. So this is gonna be one node. How many branches are connected to this node? This is 1, this is 2, this is 3, this is 4. I'm gonna assume the currents are all leaving those nodes. So this is 1, and this is 2, and this is 3, and this is 4. This is the big super node. 4 currents are leaving in the 4 branches because I don't know the current in either one of them. So let's come to the first one. So I'm gonna say sum of the entering currents to the super node equals to the sum of the leaving currents. I forgot to write the sum. Entering, nothing. Leaving, this is the first one here. V1 minus 0 divided by the resistance 2. then plus. In this branch here, voltage here is V2, voltage here is 0, so it's V2 minus 0 divided by the impedance, which is minus J4. Then I'm going to go to this 4 ohm, this current going away, plus going from V2 to V3, so it's V2 minus V3 divided by 4, plus the last one, the current going through this branch, going from this point to that point through this impedance. So what is the voltage here is V1, the voltage here is V3, so it's V1 minus V3 divided by J2. This is the second equation. Why did I say this is 1, not 3? I don't know why it said 3. So those are the two equations, 1 and 2, using the supernode. Now the third equation is at this point. So this is node 3. So at this node, I have 3 branches. One current is coming, and 2 currents, I'm going to assume they're leaving. So the coming current to the node is, this current, is 4 angle 45. Now the currents are leaving, I'm going to assume it's this way, and that is the other way. So the current going through the 4 will be now V3 minus V2 divided by 4, plus the current going into this, it's the voltage here minus the voltage here, so it's V1, so V3 minus V1 divided by J2. And this is the third equation. 3 equations, 3 nodes. Question just says find the node equations, node voltage equations, and those are the 3 equations. This question has everything, has current source, okay, has voltage source, has a voltage source between two nodes, so that is the super node. So question like this, if you can do the equations, it means you can do the equations for every circuit, no problem. Any questions? Things are okay or things are difficult? Okay, we're gonna do 2 more, hopefully. Okay, look at this question. Use the node again, and this is the mesh. So we're gonna do those ones. So I'm gonna do the mesh now here. So the question says, write the mesh equations. Now you have to know how many meshes do we have here. This is 1. This is 2. This is a 3. And this is 4. Now between 3 and 4 there is a current source. So mesh 3 and 4, you're gonna use the super mesh here. A reason, current source between 2 meshes, current source between 2 meshes. Now mesh 1 has a current source. Look at this current source. So I1 is solved because the only current going here is this current, and it's 2 angle 30. So this is the first equation. Mesh 2. So when you have a current source in one mesh, that mesh is solved. When you have a current source between two meshes, you have super mesh. So mesh 2. This is the mesh 2. I'm going to put the polarity according to my current. So 3 voltages, if I start from here, they're all negative because going from positive to negative, and positive to negative. So I'm going to have negative voltage equal to 0. Sum of the voltages equal to 0. This is how we do the mesh. So first one is 4 times the current there. There's 2 currents in this 4 ohm. The current with me is I2. The current against me is this current, I1, which is 2 angle 30. It's okay if you write I1. That's okay. If you just write I1 here, that is okay. I'm going to write that. Maybe that will confuse you a little bit. So I'm just going to say it's I1. But I1 is solved. So then this is J1. Don't forget it is J1. Time is the current going there is I2. Then here is 5. And the current with me is I2. The current minus is I3 because this is between this 5 ohm is between mesh 2 and 3. This is the second equation. Now mesh 3 and 4 super mesh. So we're going to look at this current, the 3 and 150 equal to the current in my direction is I3. The current in the opposite direction is I4. So this is the third mesh, third and fourth together. Then the fourth, we're gonna go around this. So we're gonna go like this, okay? Big mesh between 3 and 4, not the current source here. So if we start from this point, we're gonna have minus 5, I3 minus I2. Then we're gonna go up to this one here, minus and minus J4, and the current is only I4 there. Then minus J8, and the current is only I3, equal to 0. This is the fourth equation. 4 meshes, 4 equations. This is the solution. Is this okay? Is this doable? Like, can you do this?
Sir, can you repeat equation 3 and 4?
So equation 3 and 4, can you copy this? Just copy it, the answer, then I'm gonna actually erase it and do 3 and 4. Just a 3 and 4.
Okay.
So copy this, you know, screenshot or anything. So I'm gonna do 3 and 4 only. Repeat them. So I'm gonna delete this, and I'm actually gonna make these shape bigger so we can see these. Okay, so current here, I3. Current here, I4. So the polarity according to this current in this loop is like this. And the polarity in this one is like this. The polarity of the voltage. Because there is current source between them, I'm going to use the super mesh. The super mesh is actually going around like this, going into the big mesh between 3 and 4. So if I start from here, positive to negative, the voltage is drop. Positive to negative, the voltage is a drop. Positive to negative, the voltage is drop. In this 5 ohm, there are 2 currents. is I3 and I2, two currents. In the 4 ohm capacitor, it's one current, which is I4. And in the 8 ohm inductor, there's one current, which is I3. But I'm going to go from this point, negative voltage, and negative voltage, because I'm going from positive to negative. So it's -5 times the current here. I'm going in this direction. The current with me is I3, and the current opposing me is I2, because it's opposing my direction. I'm going this way. Then here, minus, and this is minus J4. This is the impedance. Times the current here, which is I4. The current in this one is only I4. Then you go minus, because going from positive to negative in a big loop. So it's J8, and the current here is I3. The sum of the three voltages equal to 0. So this is the super mesh. It means 3 and 4 combined together, the big mesh. Now the current source in between is 3 and angle 120. Where is the direction of the current source? Is in this direction. I3 is in this direction, I4 is in this direction. So this branch current equals the current in my direction minus the current opposing me. So it's I3 minus I4. Those are the two equations between 3 and 4 if we don't look at anything here. There is a super mesh because there is a current source between these two. Is this okay? Is this fine?
Yes, yes.
Now it would be a good idea to try to copy the answers here and do them in your own and try to find the same answers. And if you're not able to find the same answer for any reason, and has to make sense, not just, okay, maybe multiply by minus, maybe multiply by positive, but it should be clear that the polarity
Sir,
is like this.
why the angle is 120?
Oh, 150. This is just a typo. Thanks for that. Okay, so I'm gonna go back a little bit to one more question before we go. And I think that question should be maybe one of those. We did two meshes, we should do one nodal. Oh, this question is repeated. So question 6 is the same as question 4. Okay, so question is repeated. So that question we should do here. Oh, here says do mesh analysis and here do it with nodal analysis. Okay, so it's the same question, but two different techniques. So we can do this question with both techniques, okay? This question 4 and 6, it's the same answer. Do I have the same answer 4 and 6? Hopefully, yes, here. Okay, one says find the current, one says find the voltage. Okay, so it's the same question, but just find here the voltage and here find the current. Okay, the current in the capacitor, the voltage in the capacitor, which is, okay, so I'm gonna do this question in both techniques, nodal analysis and mesh analysis. Okay, so here's this question. We're going to use nodal analysis to find the voltage, or you can find the current as well, which is the same thing. Okay, so nodal analysis, this is the 0 reference. And that is the node V0. One equation, sum of the entering currents equals to the sum of the leaving currents. There is one entering current because the current source is given, so it's 4 angle 90. Then the other two are leaving. I'm going to use Ohm's law to find them. Current here is leaving, and current here I'm assuming it's leaving. So cross this, it's V0 minus the voltage here is actually, this is like 0 volt, okay? minus 0 divided by J6. This one here is V0 minus 0 divided by minus J3. Oh, this is 90. So this is the equation here. Now I can multiply by J6. So when we multiply by J6, 24. J is 90 times 90, so it's 180. You can even do it in your calculator. This is J means 90 degree. So 24 and 90 plus the 90. And here J6 cancels this, so it's V0. And here J6 will cancel J3 and you still have 2, so it's minus 2 V0. So this is minus 24, okay, equals to minus V0. So V0 equals to 12 volt. If you want the current in the capacitor, IC, you're going to say, okay, it's the V0 minus 0 divided by minus J3, Ohm's law, the voltage across the impedance divided by the impedance. So it's 12 divided by minus J3. This will give you 4 angle 90 ampere. This is the nodal analysis. If we use mesh analysis, oh, it's 24.
Sir?
Yeah.
Okay.
I divided. Thank you. I just saw this. Okay. This is not me not doing good. 24. I don't know why I put a 12. And here is 24. Oops, 24. Thinking of 24, writing 8, I already divided because it's divided, so it's 8. Good that you guys are actually paying attention. Now I'm gonna use mesh analysis here. So this is mesh analysis. And this is node. Okay, so when we do mesh analysis, we have 2 loops. Okay, so we're gonna do, plus I'm gonna erase this. The mesh is gone. I'm gonna use now the nodal. So this is one mesh, and this is the second mesh. Now there is a current source in between, so I'm gonna use the super mesh. Current source between these two, so super mesh. So the first equation is the current source equation. 4 angle 90 is gonna equal the current in my direction, it's I2 minus I1. This is the first equation. Now nodal is easier here because mesh, you have 2 meshes. Then the second one is the big loop. So polarity here is like this, and polarity here is like this. So if I start from this point, I'm gonna go around in the big mesh, not through the current source. So it's minus J6 I1, then minus J3 I2 equal to 0. From here, minus J6 I1 equals to J3 I2 equal to 0. I can divide both sides by J3. Okay, I can divide by J3, so it's minus, just divide by J3 to get rid of the J's. So it's minus 2I1 plus I2 equals to 0. This is the second equation. I can solve these two equations by substitution. Maybe I can say I2 equals to 2I1. Okay, from here, and substitute it there. So 40 or 4 angle 90 equal to I2 is equal to 2I1 minus I1 from this equation here. I2 equals to 2I1. I just moved this to the other side. So I substituted. So from here, I1 equals to 4 angle 90 ampere. I2 is just twice of this, so it's 8 angle 90. And this is the same as this one. I2 is actually IC, is the current going through the capacitor. So it was not even difficult, even the mesh analysis here. So those are the two techniques, and we will end this here. Assignment is gonna open soon in 10 minutes. You're gonna try the assignment. I'm gonna give you 6 times. You have to get the 10% from the first attempt, so try to be okay with the first attempt. Then you should be okay for the rest. Okay, you go 20, 30, and 40. If you have an issue with the first attempt and you tried really hard, and I see that you actually tried hard and you did not get the 10%, I'm gonna actually give you a chance. But you have to try hard, not just to click on the questions and get 0.
Sir, when is it gonna close?
Wednesday, I think 6 p.m. So not Wednesday night, but 6 p.m. So try to do it maybe once today or twice. Then Tuesday you can do it another once or twice. If you find it easy, it's okay. If you find it difficult, you have time to ask me questions tomorrow or after tomorrow. You can come to me here and ask me questions, or you can WhatsApp me or something.
You mean this Wednesday, right?
Yes. Because on Thursday, we're going to open assignment 3. So now this is a...
What, Thursday or Wednesday?
So no, it will close Wednesday, and assignment 3 will open Thursday. This is assignment 2.
Sir, what about the test?
The quiz 2 will be Wednesday night. The midterm will be next week on Tuesday, but I'll confirm by email. The midterm will be 10 days from now, I guess. What's today? It's like Sunday. Yeah, so about, yes, Tuesday, but I'll have to finish booking the room and confirm with you guys when everything is set. Do one thing at a time. Now just do the assignment and do well in it.
The midterm will include from first lesson until nodal analysis.
No, will be until 6. Nodal now is 4. We finished 4. We're going to finish 5 and 6 this week, which is their 5 and 6. They're very similar. So once we finish 5 and 6, you have assignment 3, quiz 3, and the midterm.
So the midterm will be next week?
Yes, inshallah.
Can you put the chapter 5 and 6?
I will put 5 today, and 6 is very similar.
Okay.
All good?
Yes.
Don't hesitate to come to my office and ask questions. Now you're allowed to come to the college anytime. So come and ask questions. You can even come in groups, 3, 4, 5, and we can have a room and we can do some exercises. Okay, if you need help, we don't want you to do bad. So assignment 2 is lesson 3 and 4. Assignment 3 later, at the end of the week. 5 and 6. Midterm, lesson 1, 2, 3, 4, 5, and 6. Okay, I'll see you guys inshallah.